Yeah, hi students. So in this video, I am going to talk about the concept maxima and minima. Okay, so this comes under the functions of several variables. Okay, so if you look at generally what is maxima and minima, so we are given a function, we can find the maximum and minimum value. Okay, so if you find the graph for the function, by looking at the graph, we can say this is the maximum point and this is the minimum point. But if the function is some higher order function, okay, if it is having power 3 and power 4, we are not able to find the graph of those functions manually. Okay, so in those cases, we use the concept of differentiations. Okay, so mathematician Fermat has found out the concept of maxima and minima by using the concept of derivative differentiation in that. Okay, so we are going to see that in this video. So if you are given a function y equal to f of x, right? So we can find the graph of that function. Suppose, so this is my f of x for this given function. Okay, so by looking at this graph, I can say this is my maximum point and this is my minimum point. Okay, so this is the maximum value and this is the minimum value of this graph. So here we have a concept called local maximum or minimum and global maximum or minimum. So this local maximum minimum refers to the given region. Okay, so we take a region of this and we say within this region what are the maximum points and what are the minimum points. They are called local maximum and local minimum. So global maximum and global minimum is for the entire region of this x axis and the region, right? Okay, so here we have formed this maximum and minimum value. So this maximum and minimum value, if you look at this graph, we have a deep differentiation in this, right? So this maximum point here, we have a increasing function here, and suddenly this is getting decreased. So here this function is getting decreased and suddenly it is increasing. So there is a change in this point. So these points are called the stationary points. So in differentiation, how we can obtain the stationary points? So if you differentiate the particular function at that particular stationary point, the differentiation will get 0. Okay, so that is why we are using this derivative concept in the maxima minima, right? So now we will write a problem and we will solve it. So find the maxima and minima of f of x equal to x power 3 plus y power 3 minus 12x minus 3y plus 20. Yes, so we are given the function which is f of x equal to x power 3 plus y power 3 minus 12x minus 3y plus 20. So the working procedure is So, the given function f of x comma y equal to x power 3 plus y power 3 minus 12x minus 3y plus 20. So, the working procedure is we have to find the partial order differentiations, which is dou f by dou x and then dou f by dou y, then the second order differentiations, which are dou square f by dou x square, then dou square f by dou x dou y and dou square f by dou y square. So, we name them as P, Q, R, then S and then T, right. So, these alphabets refers to the values of the first order and the second order derivatives, because we are going to use this in our calculations. Okay. So, we will find out what is this P value, Q value, R, S and then T. So, what will be this P value? So, here this P value is nothing but dou f by dou x. So, that is the partial differentiation of this function with respect to x. So, if you differentiate this with respect to x, it will become 3x square plus. So, this y power 3, there is no term x in that. So, it will completely become 0, because it is considering as a constant when we differentiate partially with respect to x. So, that is 0, and this minus 12x will become minus 12 into 1, which is minus 12. This minus 3y will become 0, and 20 also will become 0. So, finally, we have 3x square minus 12, and we are going for the value q. So, which is the value of dou f by dou y. Yes. So, now we are going to differentiate this function with respect to y partially. So, the first term will become 0. So, the second term will become 3y square and then 0 minus 3 and 0. So, this becomes 3y square minus 3. So, next we have the value of r, which is dou square f by dou x square. So, already we have done for 1x partially. So, it is for x square means we have to do that once again with respect to x. Okay. So, already we have 3x square minus 12, right. So, differentiate this term with respect to x again partially. So, it becomes 6x minus 0. So, it is 6x. Okay. And so, we can continue with this x, s and t value. So, here this s equal to dou square f by dou x and dou y. So, already we have done for dou f by dou x. So, this term can be taken and this can be differentiated y partially to obtain this value. So, if you differentiate this with respect to y, it will completely become 0, and we have the last term, which is t, that is dou square f by dou y square, which is, so already we have done this for y, we got 3y square minus 3. So, this can be done again for y. So, we will get dou square f by dou y square, so which is 6y minus 0. So, it is 6y, right. So, next we are going to find the points of stationary, that is so how do we get the stationary points? So, we already discussed that at stationary point the differentiations become 0, right. So, we take this dou f by dou x, right, that is p, that is equal to 0, and the same way I am going to replace this dou f by dou y, that is equal to 0. So, we are going to replace the differentiations are 0. So, by solving them we will get the points of stationary. So, what is dou f by dou x here? So, we get 3x square minus 12. So, 3x square minus 12 equal to 0. So, by solving them we will get equal to 12, and we can cancel, becomes 4. So x value will become plus or minus 2. So by solving the q equal to dou f by dou y equal to 0, the value of dou f by dou y is 3y squared minus 3, so which is 0. So we can write it as 3y squared equal to 3. By solving them, I will get y equal to this plus or minus 1. Okay. So now we have got the values of x and y. So the stationary points are the xy coordinates. So we have to go for the all the possible combinations of this plus or minus 2 and plus or minus 1. So that will complete the stationary points. So I am writing the stationary points here. So they are 2 comma 1 and then 2 comma minus 1, minus 2 comma 1 and minus 2 comma minus 1. Okay. So these are the stationary points we have, and we are going to calculate what is r value for this. So r is already 6x, and we are going to find out what is rt minus s square also. Then we find the maximum or minimum. Yes. So this 2 comma 1 has to be replaced for this r value and rt minus s square value. So if you replace, so r is 6x and t is 6y and s is 0. So this is what we already found out. So if you replace this 2 comma 1 in the place of r, it becomes 12, and this rt minus s square is nothing but here. So this becomes, so multiplication of these two, that is 36xy and minus 0. So this is 36xy. So if you put this 2 comma 1 in the place of that rt minus s square, 36 minus xy, it becomes 72. And this 2 comma minus 1, if you replace it here, it becomes 12, and that rt minus s square will become 36 times 2 into minus 1 will become minus 72. So this minus 2 comma 1 can be replaced here. So it becomes minus 12 and minus 72. So minus 2 comma minus 1, if you replace it here, it becomes minus 12 and plus 72. So this rt minus s square value must be greater than 0. So whenever it is positive, we can make a we can have a maximum or minimum. So if it is negative, so these points are called as saddle points. So it is neither a minimum or a maximum. So whenever it is positive, it is greater than 0, we can take a decision of whether it is minimum or maximum, depends on r value. So if it is greater than 0 and if this is also greater than 0, then this is called as minimum. And whenever this is positive and this is negative, it is called as maximum. So now we got the point in which we will get the minimum or a maximum, right? So here this 2 comma 1 will give you a minimum value, and this minus 2 comma minus 1 will give you a maximum value. If you want to find the values of this minimum value and maximum value, we have to replace in the given function f of x comma y. So, we are going to find the maximum value. So, I take this respective point, that is -2 comma -1. So, if I replace this f of -2 comma -1, it will become -8 -1 plus 24 plus 3 and then plus 20. So, it becomes, yeah, if you add them it becomes -9. So, on the other side it is 47. So, this is 38 and this is the maximum value, and the minimum value this f of the point is 2 comma 1, and if you take this it is 8 plus 1 minus 12, yeah, minus 24 minus 3 plus 20. So, it becomes, so 29 minus 27, which is 2. So, this is my maximum value and this is the minimum value of the given function, right. So, we will go for the one more example. So, find the extremum values of f of x comma y equal to x power 3 plus y power 3 minus 3a xy, right. Yes. So, the same working procedure we are going to follow here. We are going to find out the first derivative with respect to x and y and the second derivative with respect to x and y again, right. So, we will write the function first, f of x comma y is equal to x power 3 plus y power 3 minus 3a xy. So, already we know that p that refers to dou f by dou x and q value refers to dou f by dou y, and r, s and then t values. So, this r means dou square f by dou x square, and this is dou square f by dou x dou y, and here it is dou square f by dou y square. So, if you differentiate this partially with respect to x first, it becomes 3x square plus 0 minus 3ay. So, it is, yes. So, we can write it as 3ay. So, if you go for this q value, if you differentiate this with respect to y partially, it becomes 3y square minus 3ax. So, on the other side we have r, that is dou square f by dou x square. We have to differentiate this once again with respect to x. So, take this value 3x square minus 3ay. So, differentiate that again, that is 6x minus, yeah. So, here we do not find any x value, that becomes 0. So, the 6x will become the value of r. So, s means either you can differentiate this with respect to y or this with respect to x. So, if you differentiate this with respect to y, it becomes 0 minus 3a, that is we can put minus 3a, and the last value, that is dou square f by dou y square. So, this y differentiation, one more time we have to differentiate that with respect to y partially. So, that becomes 6y, right. So, these are the values of p, q, r, s, t. So, after finding this, we have to go for the stationary values. So the stationary values are yes. So the stationary points in which the differentiation gets 0. So we make this P equal to dou f by dou x, that is equal to 0. So dou f by dou y value is this one, that is 3x square minus 3ay, that is equal to 0. So by simplifying them, I can write x squared is equal to ay. On the other side, we have this q equal to dou f by dou y, that also must be 0. So this dou f by dou y value is 3y square minus 3ax, that is equal to 0. By simplifying them, I can write y square equal to ax, right. So now we have two equations, x squared equal to ay and y squared equal to ax. So by solving them, we should find the values of stationary points. Okay. So I will take this x squared equal to ay. So in one way we have to replace in the other equation. So I will square this. So if I square the equation of this, it will become x power 4 equal to a square y square, right. So now this x power 4 can be written as this is equal to, so here we have a square into y square. So instead of this y square, I will replace this ax value here. So it becomes, already a square is there, so I will write a power 3 into x, right. So this is the simplification we have, and this can be further solved, right. So I can write it as x power 4 minus a power 3 x is equal to 0. So if you take x out of this, it will become x power 3 minus a power 3 is equal to 0. So either we will get x equal to 0 or x equal to a. So these are the 2 points we get, right. So we get x equal to 0 or x equal to a. So you replace this equation value in any of the equations. So if you replace it here, it becomes so x equal to 0 means this y also will become 0, and here I replace. So if I replace this a square, again y will become a. So the points are 0 comma 0, and here we get a comma a. Okay, so these are the stationary points we get. So we write the stationary points, that is 0 comma 0 and then a comma a, and this r value, okay, which is 6x, and we write rt minus s square, then whether it is maximum or minimum. Yes. So already we know that r value is 6x, and s is, yeah, and t value is 6y. So this s value is equal to yeah, minus 3a. Yes. So if you find out this RT minus S square, it will become 36xy minus the square of this is 9a square, right? So if you replace 0 comma 0 here, that is 6 times 0, so it is equal to 0. And here, if you replace 0 in the places of x and y, we will get first term will become 0, then the next term is minus 9a square, right? And the second term a comma a, second point, if you replace it in the place of x, it becomes 6a, and this RT minus S square will become 36a square minus 9a square, that is 27a square. Okay. Yes. So now the concept of maxima minima is we look at the positive value of the RT minus S square. So if it is negative, so the if you take any value of a, it is going to be negative. Okay. So we say this is negative, and we cannot obtain any maximum or minimum value from this. So this is called as saddle point, and this is always positive. So irrespective of a value, when we are squaring, it becomes positive, and 27a square is always positive. So if it is positive, then we have two cases here, right? If a is negative, right, this 6a will be negative, and if the a value is positive, then the 6a will become a positive one, right? So we divide this here. So if a is positive, so if a is positive, then this will become positive, so that is called as minimum point. That is, and the next one is, if you take this a as negative value, right? So this 6a also will become negative. So we get the maximum value from this, right? Yes. So we will replace the values of this. So if we replace this a comma a here, it becomes thank you, Sulira.